Hello everyone. This video is on the Knewton Alta assignment for section 12.2 part 3 called Hyperbolas Not in Standard Form. Alright, so in this video I'm going to be going over a preview version of this assignment, so please understand that the questions I see in this video may not be the same questions that you see when you work on the assignment yourself. But the objectives are the same, and the structure should be similar. So I'm hoping that watching me do these here helps you out in some way when you work on the assignment on your own. And on your assignment page, you should be seeing the title, the mastery bar telling you how far along you've gotten, your objectives. It looks like there are 2 objectives. Under the current objective, you should have a question related to that objective. And then at the bottom of every question, you should be seeing a feedback button where you can send feedback to Knewton if you wish. You will not have this instructor cheat button, but you will have a more instruction button. If you're ever struggling with a topic or a question, click on this and you'll be taken to a page with some reading or some videos to study, and then you'll be given questions related to that instruction, and completing those questions is another way to make progress through the assignment. Alright, so I'm going to be assuming that you have already watched my section 12.2 part 1 and 12.2 part 2 videos. So I'm going to be assuming that you know what the standard form equation of a hyperbola is and how to graph one. Right, how to identify the vertices and the center and the asymptotes and the foci, right, all that stuff from section 12.2 parts 1 and 2. Alright, so the first objective I'm looking at here is graph a hyperbola pardon me, from an equation given in general form, so not in standard form. Right, you see the equation here of this hyperbola is definitely not an equation in standard form. Right? So we're asked to find the standard form of the hyperbola given the equation, and use the information to graph the hyperbola. Right? Move the draggable points to the correct center and vertices and toggle the correct orientation. Right? Again, if you did part 1 and part 2 of section 12.2, you should know how to graph this stuff. Right? You should know how to use this here. So, I'm going to write this equation out. We have 16x squared minus 9y squared plus 72y, and then minus 288 equals 0. And clearly, this is not in the standard form for a hyperbola. Right, the standard form looked like this. It was, some quantity x minus h squared divided by a squared, right, divided by some number, minus y minus k squared divided by b squared equals 1, or the other way around where you have the x term second and the y term first, right? Y minus k squared divided by a squared minus, and then x minus h squared divided by b squared equals 1. So it's not in standard form yet, but I want to put it in one of these forms. And the way we're going to do that is very similar to how we did changing equations to standard form for circles or ellipses. Right? If you saw my section 12.0 video on circles, or the section 12.1 videos, especially section 12.1 part 3, in those videos I went through an changing an equation like this into the standard form by completing the squares, right? So the way we did that was completing the square. We complete the square on the x terms and y terms, right, on x's and y's. Now, for this particular example, I don't need to do it on the x's, because you see this, there's an x squared term, but there is no x to the first term. So I don't need to do it on the x's. But the y's I do. Remember, to complete the square, the coefficient of the squared term has to be positive 1. Well, here it's negative 9. Don't forget the negative. So from these y terms, I'm going to factor out negative 9. Okay? So on my next line, we have 16x squared. And then I'm factoring out negative 9. And when I do that from just the y terms, we'll have y squared and then, minus 8y. Because negative 9 times negative 8y would be positive 72y, like I had originally. And now inside the parentheses, I can complete the square on the y's, right? There's a 1y squared now. So I'm going to leave some space for that number we're going to add to complete the square. And then, the only terms that really concern you in the beginning when you're completing the square, thinking about completing the square, are the variable terms. So I'm going to add this 288 to the other side. So we have positive 288 on the other side. All right, so now comes the completion of the square. Again, the x squared is already a square, so I don't need to do it for x's. There's no x to the first power term. But on the y terms, y squared minus 8y, remember how to complete the square. You take half the linear coefficient. Half of negative 8 is negative 4. Square that. That'd be positive 16. Now you got to be real careful. I see this mistake made way too often. I wrote positive 16 in this set of parentheses. So that didn't mean I added 16 to the left side. So don't just write plus 16 on the right side. All right, it's an equation. You got to keep things balanced. You have to remember what you factored out. This negative 9 was factored out earlier. If I were to redistribute, if I put the plus 16 in here, if I were to redistribute the negative 9, that would give me my minus 9y squared, the plus 72y, and then putting plus 16 in here, times negative 9 would give me minus 144. So adding 16 in here really puts minus 144 on the left, so I have to minus 144 on the right side as well. And I hope that makes sense. That's 16 times the negative 9 that was factored out. That's negative 144. I'm doing that though to keep it balanced. Alright, so now I have my squares. 16 times x squared, right, that's a square, minus 9 times, and then y squared minus 8y plus 16 is the quantity y minus 4 squared, equals, and then 288 minus 144 is 144. Okay, great, and I'm almost there. I'm almost like this first version of the standard form, where I have a something with x squared minus something with y squared equals a number. But that number on the other side in standard form needs to be 1. So now comes, just turn this 144 into 1 by dividing everything by 144. Right, if I divide 144 by 144, it's going to be 1. And the nice thing here, they're being very kind to us, is that 16 and 9 go into 144 evenly, right? We know that 16 times 9 is 144. So in this first term, 16x squared divided by 144, 16 goes into 144 9 times, so that'll be x squared divided by 9. And then we have minus, and then 9 goes into 144 16 times, so you have the quantity y minus 4 squared divided by 16 equals 1. And here is the equation of our, it's the same equation as the beginning, it just looks different. They're the same equation, but this is now in standard form for a hyperbola. And And it should be easy to graph. Again, I'm assuming you went through sections 12.2 part 1 and part 2. The center would be 0 for x, 4 for y. Right? The center is at 0, 4. The value of a squared is 9, so a is 3. Right? And since x squared is the lead term, right, it's x squared minus y squared, we're going to go 3 units to the right and left. The transverse axis is horizontal. So 3 units right of the center and 3 units left of the center. Those are the vertices. Right? So one vertex is at 3, 4. The other vertex is at negative 3, 4. And again, check that out. These are actually solutions of this equation, and therefore the first equation they gave us too. Put in 3 for x and 4 for y, and you'll see that equation is true. Put in negative 3 for x and 4 for y, you'll see that the equation is true, and I leave that to you to check it out. Then the value of b would be 4, right? B squared is 16, so b is 4, and then I go 4 units above the center to 0, 8. Now this is a different color because it's not actually a point on the graph. Right? 0, 8 is not a solution to this. If you put in 0 for x and 8 for y, you're going to get 0 minus 1 equals 1. That's not true. And then go 4 units below. So the origin, these are the co-vertices they were calling them. But again, those aren't points on the graph. Those just help me with a little guide box. Right? I had this little box that I dashed. It's a little dotted box. It doesn't actually belong to the graph. It's not actually part of the graph of the hyperbola. It's just a guide. And then through the corners of this box and the center goes the asymptotes. Remember, there were these asymptotes that the graph tended toward as you move further away from the center. And so something like that. And the slope of this one was 4 thirds, and the slope of this one is negative 4 thirds, and they both go through the point 0, 4. So here's y equals 4 thirds x plus 4, and here's y equals negative 4 thirds x plus 4, right? There's your two asymptotes, but we're not asked for that. We're just asked to make a graph. Once you have the vertices and the asymptotes, you should be able to make a rough sketch, these curves that approach these asymptotes, using the box as a guide here. Drawing these curves that approach the asymptotes as you move further away from the center. Alright, then what I'm going to do, just to see that my graph is correct, I'm going to graph both of these in the Desmos website, and you'll see that they're the exact same thing. So back on, this is a free online graphing calculator, right, at desmos.com. So first I'll enter the equation they gave us, right, the equation we started with, 16x squared minus 9y squared plus 72y minus 288 equals 0. And you can see the hyperbola. You can hopefully see the two branches of the hyperbola here. Then the equation we changed it to was x squared divided by 9 minus the quantity y minus 4 squared divided by 16 equals 1. And look at that. I know you probably can't tell the difference, but if I turn this off and on, you'll see it's the exact same picture. It's the exact same graph. So yeah, did a good job. But back here, all we have to do is move these points around. Now this, again, the transverse axis was horizontal, so I move this green point so that it changes the orientation. Come on. All right, there we go. So I move that green point onto the x-axis here so we get the curves opening left and right. The center was at 0, 4, and so I'm going to move the center to the point 0, 4. I think you can click on it and see that it's actually there. The vertices were 3 units to the right and left of center, so one of the vertices has to be at 3, 4, which I said earlier on my drawing. And then the co-vertices, or the top and bottom of this box, have to be 4 units above and below the center. So here that was at 0, 8. right? And the other one would be at the origin, and this is looking like the picture I drew by hand, and also the picture you saw in Desmos. Alright, then after you submit an answer, it'll tell you if you're correct or incorrect, and then give you some sort of answer explanation. Please read through these answer explanations just to make sure you understand why something was correct or incorrect, and hopefully you can learn from your mistakes for future questions. Okay. Alright, so this one is, convert an equation of a hyperbola into standard form. So it's basically the same stuff. Alright, I'm given some equation that's clearly not in standard form, and through use of completing the square, on the x's and y's, I'm going to put it in standard form. Right? And if you notice the standard form, notice how the positive term is always first and the negative term is always second. So I'm going to try to do that in these equations they give me as well. So like here's what I mean by that. The equation they're writing for me now, is negative 9x squared plus 54x and then plus 4y squared minus 8y minus 113 equals 0. So again, like I just said a minute ago, I would rather have the positive square first than the negative one. So I'm going to put the y terms first. And from the y terms, if I want to complete the square, I need to factor out a 4. So we have 4 times the quantity y squared minus 2y. Alright, and then because I can complete the square in here, I'm going to leave some space and then close those parentheses. And then I'll put the x stuff because there's a minus x squared. Negative term should go second in standard form. And again, I can't complete the square right now. I need the coefficient of x squared to be positive 1. Right now it's negative 9, so I can easily fix that by just factoring out the negative 9. So I factor out negative 9, and then if I do that, we'll have x squared minus 6x, and then I can complete the square on the x's. So I'm going to leave some space, and close the parentheses. And equals, and then, add 113 to both sides, get 113 over here. Okay, now comes the completing the square part. On the y's, I'd be adding 1 in here in the parentheses. But remember, you got to remember what you factored out. If I add 1 in here, that's really adding 4 to the left side, right? 4 times 1 is 4, so I need to add 4 to the right side. And then for the x's, I'd be adding 9 to complete the square. But remember, I factored out a negative 9. Negative 9 times 9 is negative 81. So I need to put a minus 81 on the right side as well. So pay attention to what you factored out. Okay. Alright, so now we have 4 times, and then y squared minus 2y plus 1 is y minus 1 squared, minus 9 times, and x squared minus 6x plus 9 is x minus 3 squared, equals, and this is 117 minus 81, that'd be 36. Which again, they're being very kind to us. 36 happens to be a multiple of 4 and 9 over here. This is very nice. So then to get it in a standard form, I'm going to change this 36 into a 1 by dividing everything by 36. So now the left side we have y minus 1 squared divided by 9. Right, 4 goes into 36 9 times. Minus, and then the quantity x minus 3 squared divided by 4. Right, 9 goes into 36 4 times, equals 1, and here you have it. There's the equation of this hyperbola. I think I said ellipse earlier, I apologize. There's the equation of this hyperbola in standard form. y minus 1 squared over 9 minus x minus 3 squared over 4 equals 1. And then if you'd like to double check yourself, again, I'm going to go back to that Desmos site. I'll just enter the two equations, the equation we started with and the equation I ended up with, the standard form equation, and see if they actually give you the same graph. So negative 9x squared plus 54x plus 4y squared minus 8y minus 113 equals 0. So there's this hyperbola. And the graph we ended up with in standard form, y minus 1 squared divided by 9 minus the quantity x minus 3 squared divided by 4 equals 1. And look at that, right on top of it. It's exactly the same picture, exactly the same hyperbola. So that's correct. Right, so y minus 1 squared over 9 minus x minus 3 squared over 4 equals 1. That's this option here, and that should be good. Yeah, and we're just doing this for every single one of these problems. All right, just sometimes you're graphing and sometimes you're just changing the standard form, and that's it. All right, so another one. All right, so this time, they're going to have me type it out instead of just do a multiple choice one. All right, and this time I won't go to Desmos. I'll leave the checking to you if you want to do that. All right, so we have 16x squared minus 96x, then minus 4y squared plus 16y plus 64 equals 0. All right. So from these two terms, the x terms, I'm going to factor out 16. And then from the two y terms, I'm going to factor out negative 4. Don't forget the negatives. And then I'm just going to subtract 64 from both sides and get rid of this constant term. So we have 16 times the quantity x squared minus 6x, and now I'll have some, I can complete the square on the x's now. I'll leave some space, close the parentheses. We have minus 4 times the quantity y squared minus 4y, right? Because that would give me positive 16y, and then I can complete the square on the y's. So I'll leave some space there, close the parentheses. Equals negative 64, right? 0 minus 64. All right, now comes the completing the square part. On the x's, I'd add 9 in here. But remember, we factored out 16. 9 times 16 is 144, so I'd be adding 144 to the other side as well. And then on the y's, I'd be adding 4 to complete the square. But remember, I factored out negative 4. 4 times negative 4 is negative 16, so I got minus 16 over here as well on the right side. And just don't forget what you factored out. Okay, pardon me. All right, so this is 16 now times, and then this x squared minus 6x plus 9 is the quantity x minus 3 squared minus 4 times, and then y squared minus 4y plus 4 is y minus 2 squared. All right, and then on the other side, negative 64 plus 144 would be 80, minus 16 would be 64. And it just so happens again that 4 times 16 is 64. Again, they're being very, very kind with the examples they're giving us here. And then to turn this side into equals 1, and just divide everything by 64. And simplify. Alright, so the first term on the left, we have x minus 3 squared divided by, and then 16 goes into 64 4 times, minus, and then the quantity y minus 2 squared divided by, and then 4 goes into 64 16 times equals 1, and this is exactly what they wanted here, the equation written in the standard form for a hyperbola. And that's what I'll type. And again, you can double check by plugging these into Desmos and seeing that they're the exact same graph, the exact same hyperbola. But like I said earlier, I'll leave that to you. So we have the quantity x minus 3 squared divided by 4 minus the quantity y minus 2 squared divided by 16 equals 1. And that should be good. Wonderful. Alright, and again, I'm doing the same thing every time here. Just sometimes I'm graphing and then sometimes I'm not. So here's one where we're going to graph. So once again, I'll write this out. We'll change it to standard form through use of completing the square. Alright, so we have negative 4x squared minus 40x plus 9y squared plus 36y minus 100 equals 0. Alright, so I'm going to start with the y's because they have a positive square as opposed to the x's with the negative coefficient on the square term. So from the y terms, I factor out 9. We'd have 9 times the quantity y squared plus 4y. And I'll leave some space to complete the square. Then from the x terms, I'd factor out negative 4. So you have minus 4 times the quantity x squared plus 10x. And then leave some space to complete the square. And then equals 100. I'd add 100 to both sides. Alright, now to complete the square on the y's, I'd add 4. But remember, 9 times 4 is 36, so I'm going to add 36 to the other side to keep it balanced. Then to the x terms, I'd be adding 25. Negative 4 times 25 is negative 100. Alright, so I got to put negative 100 on the other side. Then the first term is 9 times the quantity y plus 2 squared minus 4 times the quantity x plus 5 squared equals 36. And I divide everything by 36, and you have y plus 2 squared. 9 goes into 36 4 times, so that'd be y plus 2 squared over 4 minus, and then x plus 5 squared divided by 9, right? 4 goes into 36 9 times equals 1, and there's the standard form. Now they did want us to graph it though, right? So I'll make a very quick sketch over here, and you can go to Desmos and check it, but the center, remember, pay attention to where the x is and the y is. The x value of the center would be negative 5, and the y value of the center would be negative 2. So negative 5, negative 2 for the center. And because it's y squared minus x squared, the transverse axis will be vertical. So a is 2, right? A squared is 4, a would be 2, and I'd go up and down 2 units for the vertices. So one vertex would be at negative 5, 0, and the other vertex would be at negative 5, negative 4. Right. And then the value of b would be 3. Right, so right 3 from the center, go to the right 3 units. There's a co-vertex at negative 2, negative 2. Again, that's not a solution, different color. And then left 3 to negative 8, negative 2. Again, co-vertex, not a solution. And then through the co-vertices and vertices, I make this little box, this guiding box here. And we have the asymptotes going through the corners of that box in the center. And once you have the asymptotes in and the vertices in, you can make a rough sketch. And you could also find the foci and stuff, but we are not asked to find the foci for a lot of these problems, it seems. Just remember that c squared was equal to a squared plus b squared, right? Just keep that in mind if you're ever asked Asked to find the foci, that should help. Yeah, this is all we're asked to do here is make this graph. So the curves, the transverse axis is already vertical. The curves are opening up and down, so that's good. Don't need to move the green point. Then the center was at -5, -2. Right, so I move the center over to -5, -2. Just click on it to make sure. The vertices were 2 units above, which, -5, 0 is one of them. That's good. And the co-vertices, or the other edges of the boxes, were 3 units to the right and the left. That's 2 units to the right, so I need to move this there. There we go. That should be good. Excellent. Alright. Moving right along here. So yeah, another one of these where we're asked to type it out, write the equation in standard form. So yeah, more of the same, just a lot of factoring out and completing the square and all that. Just remember what you factored out, so you know what you have to add to the other side. So I have 4x squared minus 8x, then minus 9y squared minus 54y minus 113 equals 0. So again, I'll factor out 4 from the x terms. 4 times the quantity x squared minus 2x. Leave some space to complete the square in the parentheses there. From the y terms, I'll factor out -9. So you have -9 pulled out times y squared plus 6y. And leave some space. And then I would add the 113 to the other side. Completing the square on the x's, I'd be adding 1 in here, but then remember the times 4 would be 4, so I'm going to add 4 to the other side. Completing the square on the y's, I would add 9. -9 times 9, -81, so -81 on the other side. This is pretty similar to a problem we saw earlier. This is 4 times and then x minus 1 squared minus 9 times the quantity y plus 3 squared equals 36, right? We saw this one earlier. 113 plus 4 is 117. Minus 81 would be 36. And then dividing everything by 36, we have x minus 1 squared divided by 9 minus the quantity y plus 3 squared divided by 4 equals 1. And this is what they want here, the equation in standard form for a hyperbola. Alright, and just typing that in. So x minus 1 squared divided by 9 minus y plus 3 squared divided by 4 equals 1. And that should be good. And again, you can go to Desmos, graph the first equation, graph this equation, and you'll see that they're the same exact graph, the same hyperbola. At least they should be. Alright. Okay, so one more from this objective. Alright, so this one, you got -x squared plus 4x plus 25y squared plus 150y plus 196 equals 0. So I'm going to just, on my piece of paper, I'm just going to jump to where I factor 25 out of the y terms, -1 out of the x terms, right? Because that's not positive 1x squared, it's -1. So I'd factor out -1, or just a minus sign, from the x terms, and then subtract 196 from both sides. So I'm just going to jump to that step. So I factored 25 out of those y terms, and it would be y squared, 25 times the quantity y squared plus 6y. Alright, 25 times 6 is 150. And then some space. And then I factored a -1, just a minus sign, out of the x terms. We have x squared minus 4x then, because it was a positive 4x. So I'd have minus 4x if I factor out -1. And leave some space to complete the square on the x's there. equals, and then I subtracted 196 from both sides, so negative 196 on the other side. Alright, now the completion of the squares. Here I'd be adding 9. Now 9 times 25 is 225, so I'm adding 225 to the other side. And then in here, I'd be adding 4 to complete the square, but then times negative 1. So minus 4 on the other side. So that makes negative 200 and, plus 225. There's 25 on the right side. And then 25 times the quantity y plus 3 squared minus the quantity x minus 2 squared. And I divide everything by 25. So I got y plus 3 squared minus, divided by 1. 25 divided by 25 would just be 1. You don't have to write that. X minus 2 squared divided by 25 equals 1. And there's the standard form for that equation. And again, if you want to graph them both just to see, you can. So y plus 3 squared minus x minus 2 squared divided by 25 equals 1. Great. Alright, so that objective's done. And now I just got a couple more graphs to do. But again, I'm doing the same thing every time. I'm taking some equation that's not in standard form and through use of completion of the square, putting it in standard form. But now we'll be graphing again. Alright, so I'd factor a 9 out of the x terms and negative 16 out of the y terms and then add 252. Right, so I'm just going to jump right into that step. So I factored a 9 out of the x terms. There was x squared plus 36x. So that'd be 9 times the quantity x squared plus 4x. And leave some space to complete the square on the x's. Then we had minus 16y squared minus 96y. So if I factor out negative 16, you'd have the quantity y squared plus 6y. And leave some space. And then equals, and I was adding 252. So 252 over here. Alright, now we complete the square. On the x's, I'd be adding 4, and then 4 times 9 is 36. Right, so I'm adding 36 to the right side. On the y terms, I'm adding 9, and then negative 16 times 9 is negative 144. And that's 288 minus 1. That's 144 on the right side. But you know what, I'm just going to divide by 144 and write the squares. So we have, 9 goes into 144 16 times. This is the quantity x plus 2 squared divided by 16. Minus, and then 16 goes into 144, 9 times. So we have the quantity y plus 3 squared divided by 9 equals 1. And there's a standard form, but we're asked to graph as well. Negative 2 for the x value of the center, negative 3 for the y value of the center. So negative 2, negative 3 for the center. Then a would be 4, right? A squared is 16. So I go from the center, right 4, left 4. It's an x squared minus y squared. Transverse axis would be horizontal. So a vertex would be at 2, negative 3. And then I go left 4 from the center. And you'd have another vertex at negative 6, negative 3. Those are actually solutions of the equation we were given. And then the value of b is 3, right? B squared is 9. So from here I go up 3. There's a co-vertex, negative 2, 0. And then down 3. There's negative 2, negative 6. And that forms that helps me form that box. And I can draw the asymptotes through the corners and the center. And then once I have the asymptotes in, I can draw a rough sketch of the hyperbola, right, from the vertices, using the box as a guide, and approaching these asymptotes as we get further away from the center. Alright, so like this. That's what I want. Alright, so again, the curves are opening left and right, not up and down, so I need to change the orientation like that with the green point. Then the center is at -2, -3. So I'm going to move the center over to -2, -3, just make sure it's actually at the right spot. Great. The one vertex to the right was, 4 units to the right. That was at 2, -3. That's a vertex. And then the top and bottom of this box were, where the co-vertices were with 3 units above and below. So there. And that should be the same picture that I drew by hand. And again, you can check Desmos too. Wonderful. Alright, and I should have just one more of these, which once I write the equation, I am just going to go straight and graph it on the assignment. Alright. So again, I'll just skip to the step where I would factor 25 out of the x terms and -9 out of the y terms and add 206 to the other side. So I'm going to jump to that step first. So we had 25 pulled out of the x terms, and then you have x squared minus 4x, because it was 25x squared minus 100x. Leave some space to complete the square. Then I'm going to factor -9 out of the y terms. It'd be -9 times y squared plus 6y. Because it was -9y squared minus 54y, and then leave some space to complete the square. And then there was -206 on the left. I would add 206, and then there's positive 206 on the right. Alright, completing the square, I would add 4 to the x terms here in the parentheses, and then 25 times 4 is 100. So I'm going to add 100 to the other side to keep it balanced. And then here I'd be adding 9 to complete the square on the y's. -9 times 9 is -81, so I put -81 over here. Alright, so 100 minus 81, it's 19 plus 206. This is 225 on the other side. And then I would divide everything by 225 and write things as squares. So we end up with x minus 2 squared. And then 25 goes into 225 9 times. So it would be x minus 2 squared over 9. Minus, and then the y squared plus 6y plus 9 would be y plus 3 squared. And 9 goes into 225 25 times, equals 1. Alright, there we go. And I'm going to graph it now. And A is 3, B is 5. It's going to be doing this, right? The transverse axis should be horizontal since it's leading with the x squared. Alright, so the center will be at 2, -3. And, it's got to have a horizontal transverse axis, so like that. And then the center, the curves are opening right and left. And then 2, -3 for the center. And then A was 3, so the vertices should be 3 units to the right and left of center. So 5, -3, and -1, -3 like that. And then B was 5, so the top of this box, the bottom of this box should be 5 units above. So that's 2, 3, 4, 5 like that. And there's the graph of the hyperbola that's being described by that equation. Great. So yeah, so I was doing the same thing every time, factoring something out, completing the square, making sure you pay attention to what you factored out so you know what to add to the other side, and then get it in that standard form. And once it's in standard form, and if you've worked on 12.2 part 1 and part 2, once the equation of a hyperbola is in standard form, you should be able to pretty easily identify the center, the vertices, the asymptotes, the foci if they ever ask you for them. Alright, those should be easily identifiable once it's in standard form. And great, and that should be it for this preview version of this assignment. Like I said at the top of the video, the questions I saw here may not be the same questions you see when you work on the assignment yourself, but the objectives are the same. The structure should be similar. So I'm hoping that watching me do these here helps you out in some way when you work on the assignment on your own. And thank you very much for watching.